Hello and welcome to the PSV sizing. In the last session, we have talked about blood discharge scenario and fire exposure, especially wetted fire exposure. And when it comes to the PSV sizing, it could be quite challenging to find out if it's applicable uh, to consider PSV sizing for wetted or unwetted fire scenario. And in this session, I want to just focus on, and we will discuss about control valve failure, how to find the maximum flow rate when a valve is fully open or fully closed. Okay, just stay with me and learn how to find those consideration. So the first question that we want to answer is that what is a CV failure? And we want to learn the concept and the meaning of the CV failure, and then go to the next question, which is that if the CV failure or control valve failure is applicable within our system or not, when the high pressure and the low pressure systems are connected with a valve. And finally, we will answer how to find relief load when the CV failure is applicable. So let's just focus on the definition of control valve failure. According to the valve design datasheet, the valve design bases are classified into two categories, which is the fail open or fail close. Design basis of valve are just generally considered these two types. And fail open means that the valve opening is 100% and it's fully open. And the fail closed means that valve is totally closed, right? You know that. And it doesn't really matter if it's this valve is its failure is just because of mechanical failure or loss of instrumental air, right? It's just what really matters is that this valve is failed, and this considered that this valve is open, that this valve's opening is 100%, and this valve actually pass more flow rate than we expected. Yeah, when we should consider what we want to do with those intended flow rate or intended pressure that may have come, that may encounter it when the valve is fully open. As you know, that the valve are operating within a range of 20 up to 80% opening ranges, right? Consider this simple example with a valve that its upstream pressure is 25 bar gauge and reduce the pressure into 8 bar gauge, while the set pressure of PSV that installed on this vessel is 12 bar gauge, which is the same as the design pressure of the vessel. And when this valve fails to open, and actually its opening is 100%, this actually its flow rate exceed our intended flow rate that we designed according to it. And this 25 bar gauge upstream pressure or high pressure stream side of the control valve can pressurize the vessel at the downstream. And the vessel at the downstream, its pressure, reached to 25 bar gauge, while the set pressure of a PSV is just only 12 bar gauge. So we need to consider actually control valve failure scenario in such cases. When it can't pressurize the downstream, well, it doesn't really matter if it's a downstream or the upstream vessel equipment or whatever it is. It just can't pressurize the equipment that it connected to. And we should consider control valve failure. And to give you a general rule to have a better understanding, actually you have learned how to analyze it. You just should consider if this actually particular failure control valve can pressurize our equipment or not. That is simple, and you know how to find it out. But I want to give you a general rule, a rule of thumb to find it out if the control valve failure is applicable or not. And here is the simple equation, or actually stated that many design practices are rely on, and that inequality states if the maximum operating pressure is greater than 1.1 times set pressure of the downstream equipment. So a control valve failure should be considered. Within this case, as you can see, 25 bar gauge exceed 1.1 times 12 bar gauge. And this means that control valve failure should be considered and should be analyzed. And we want to learn how to find its relief load. And you might be wondering, where does this parameter, 1.1 comes from? And you should refer to your design code, if it's API or ASME design code or whatever your design specification is, you should refer to your specification. It may have another factor, and you should consider those value. And since we generally refer to ASME, design specification, and its general value is 1.1, and within this case, control valve failure should be considered, as you can see. But okay, we now find out that control valve failure is applicable within this system. I want to discuss about how to find its maximum flow rate within this control valve when it fails to open. But let's just focus on its bypass, because it's I think its bypass is not as hard as its control valve. So let's just focus on its bypass and consider the bypass. Have to consider bypass flow rate within this case. According to API 521, if the bypass is just only open during the maintenance, the amount of actually flow that this bypass can pass in the failure is 0. That's quite simple, right? And if it's open during normal operation, its flow rate, actually, to give you a general rule, is equal as the maximum flow rate that the control valve can handle, right? But you should consider at relieving condition. So I want to just consider relieving condition within this system. As you can see, we have the same example. I want to discuss about the relieving condition. And once you learn the concept and the relieving condition, we want to just find it out, how to find flow rate, max flow rate within the control valve failure when it's phase open. When it's opening is 100%. So consider the same example. Its upstream pressure is 20 bar, and this valve can reduce the pressure into 8 bar, and the design pressure of the vessel is 12 bar gauge. And as you know, this when this valve is actually fails, this can pressurize the vessel, and we should consider to find the maximum flow rate when this valve is fails to open. So according to API 521, it directly states that the relief load within these cases equals maximum flow rate, maximum inlet flow rate minus normal outlet flow rate at relieving condition, right? You don't have to find the normal actually outlet flow rate. You should refer to your material balance, and you know how to extract those value from your material balance and substitute those value within this equation. So, but I want to just discuss about the relieving condition. According to API 521, we have two type of contingency or hazard when it comes to the PSV sizing. The first one is the operational contingency, and the second one is the fire contingency that is less likely to happen when it comes to the PSV sizing. So we have discussed about the fire scenario, wetted fire scenario, and finding relieving pressure within the fire scenario, which was 1.21 times set pressure of the PSV, and you know how to find the relief pressure with this equation. But just focus on operational contingency, which is, in this case, we have control valve failure, and the operational contingency, such as control valve failure, block outlet, this kind of scenario are considered as operational contingency. And we have control valve failure, and for relieving pressure, we should multiply set pressure of the PSV by 1.1, which is, in this case, we have 12 bar gauge times 1.1, which is 13.2 bar gauge when this valve is fully failed to open. Yeah, when it's actually its opening is 100%, and at relieving condition, its upstream pressure is 25 bar gauge, while the downstream pressure is not operational pressure, which is 8 bar at all. And when it fails, its operational, its relieving condition should be considered, which is, in this case, as I have discussed, have to find its relieving pressure, and its relieving pressure is 13.2 bar gauge. And we should find the maximum flow that this valve can handle when its upstream pressure is 25 and its downstream is 13.2 bar gauge. Yeah, that's the relieving condition. So once you find the maximum inlet flow in the normal outlet flow. And by knowing that if your bypass is just open at operational condition or maintenance, which we have discussed about it according to API 521, you can find the relief load and substitute those value within this equation, right? And you find consequently, you can calculate designation area or the size of orifice for your PSV. But they have discussed about all the parameter, but consider they have a valve with a given CV, which is in this case is 120 US gallon per minute. But within I want to talk about how to calculate maximum flow rate of flow rate when this valve is fully open and its CV is given, which is 120 US gallon per minute. And by knowing its upstream pressure and its downstream pressure, I want to discuss how to find the maximum flow rate that this valve can handle when it fails open within the next video in high sys dynamic mode. I hope you found this tutorial helpful. Take care. Have a good time. Bye.